So let's take a look at this circular motion slash centripetal force problem. First, we're asked to find the tangential velocity. Remember, we have two kinds of velocities. We have tangential velocity, which is the velocity of this object as it goes around the circle. That's the linear speed. That's the direction it would go if you were to cut off the force. It would keep going along this tangent line, like so. And we need to find out what that velocity is. There's another kind of velocity called rotational speed, which is how many revolutions per second, and it's related to the period, how long to go around once. So what we're asked to calculate is to calculate the time required to go around once. In other words, the period. The tangential velocity is calculated like any other velocity from a distance over a time. Now in this case, the distance is the distance around the circle, otherwise known as the circumference, and the time is the time to go around once, otherwise known as the period. So the distance to go around is going to be 2 pi r, the equation for the circumference of a circle, and the time is going to be the period, t. So let's solve this for t because that's what we want to find out. T is equal to 2 pi r divided by the tangential velocity. We're told that the r, the radius, is 2.4 meters. Notice when I substitute in, I have the units, and I've also written the formula before I plug anything in. And the tangential velocity is 4 meters per second. Put that into your calculator, and you should get 3.77 seconds. Don't forget the unit on the final answer. The next question is a little tougher. It says, describe a change that would quadruple the magnitude of the centripetal force. So we want the centripetal force to get 4 times as big. So you want the centripetal force to be 4 times as great. So how are we going to do that? To answer this question, you need to start with the relationship. Centripetal force is always equal to mass times the centripetal acceleration, AC. But remember, AC is tangential velocity squared divided by the radius. So this is mv squared over r. We need to get this down to 2 variables at a time. So what I want to do is I want to look at it with centripetal force and see how that relates to, for example, the velocity. Well, I'm going to assume that m and r don't change, so I'm going to treat those as if they're 1. So that means the centripetal force is going to be proportional to the squared. It's not an equal sign because to get the actual value you need the m and the r, but to qualitatively figure out how it changes you don't need to know that. So the centripetal force is 4 times greater. What's going to happen to the tangential velocity? Well, you're going to take the square root of both sides, and you're going to see that the tangential velocity would have to be twice as big in order to get you 4 times the force. Take the square root of both sides. But that's not our only option. We could also look at how mass is related to centripetal force. So in this case, we're going to write Fc is proportional to m, and we're going to assume v and r don't change, so you can treat it as if they're 1. This one's actually pretty easy because if the centripetal force gets 4 times as big, that must mean the mass gets 4 times as big, or the force is 4 times as big when the mass is 4 times as big. Sorry about that. And our third option would be to look at the relationship between centripetal force and radius. In this case, what we're going to assume is that the m and the v don't change, so we'll treat them like they're 1. You get Fc is proportional to 1 over r. So if 4 is proportional to 1 over r is proportional to 1 over 4. So what that means is we can get the desired quadrupling of the force by doing one of 3 things. The first thing you can do is you can double the tangential velocity. So double the tangential velocity. Second thing we could do, and probably the easiest, is we could quadruple the mass. And the third thing we can do is we can quarter the radius. All of these will get you the same desired effect, which is to quadruple the force. Now, you only need to put, and really only should put, one of these. I just wanted to show you that you can do any of these things. And these numberless problems tend to be what gives students some of the most trouble. And here, in the last question, you're asked to label a vector A showing the direction of the acceleration. Well, as this car goes around in the circle, the reason it keeps going around in the circle and not flying off at a tangent is there is a force that keeps changing its direction. So even though the velocity doesn't change magnitude, it is changing direction. And that's because the force is always directed towards the center. And hence the centripetal acceleration is always directed towards the center. So that's going to be the direction of the acceleration.